Welcome back to Algebra 1, Chapter 7. We're on Section 2. So we're going to talk about dividing. So in Section 7.1, we multiplied, we got rid of parentheses, we knew what to do when we had a power to a power, or when we had like x to the second times x to the ninth. Now we're going to talk about what to do when we're dividing. So we're going to have fraction bars in these problems. So the first thing and the easiest thing is something like a problem like x to the seventh over x to the second. We don't want that fraction bar in there. It's not a monomial. We've got two x's and we can combine them. If we like to write this out the long way, I've got 7x's in the numerator. I've got 2x's in the denominator. And then we can think about simplifying fractions. If we divide by an x and an x, we can cancel them out one at a time. Cancel out in a pair, one from the numerator, one from the denominator. So how many x's do I have left? And are they in the numerator or the denominator of that fraction? I've got, it looks like x to the fifth power. I could write over 1 because there isn't anything left, and 1 is a placeholder in a fraction. Or I would just write x to the fifth. But we do recognize there's a fraction, just like when we're doing a slope. If our slope was 3, we knew it was 3 over 1. Our shortcut for this is keep the base of x in this case, subtract those exponents. A 7 minus 2 gave us a 5 for our new exponent for our answer. Power of a quotient looks something like x over 5 to the third power. So this one's an interesting one. Our shortcut is to distribute again. So when we forget the parentheses with the exponent on the outside, we put that to both the numerator and the denominator. If you like to write these out, this means that I've got 3x over 5 that I'm going to multiply, right? The exponent tells me how many times to write that. So if I look at that as an x over 5 times an x over 5 times an x over 5, my numerator would be x times x times x, or I would want to write that as x to the third. My denominator would be 5 times 5 times 5, which is not 15. It's 125. Check it on your calculator. So when I distribute that exponent, I had an x to the third power. And then I also had a 5 to the third power. So that's where that came from that shortcut. Zero exponent is my favorite one. Here's what a zero exponent says. Anything to the 0 power equals 1. So if I gave you a problem like x to the 15th, y to the 24th, z to the 5th, all to the 0 power, that whole thing is going to tell me what is my final answer. Don't be fooled, that's a big 1. Now if I had something like this, x to the 4th, y to the 0, z to the 5th. The 0 is only on the y in this case. It's not on that whole set of parentheses. So that means this y becomes a 1, but I still have an x to the 4th and a z to the 5th power. So double check to see where your 0 exponent is. Whatever that is on is a 1. You can just cross it out because it's like timesing by 1, and 1 doesn't change anything. And last but not least, a negative exponent. We mentioned negative exponents in the last section because we're not allowed to keep negative. We have to take care of them. So a negative exponent, we're going to use the reciprocal of the base and then make the exponent positive. So my base in this 5 to the negative 2 power is 5, right? What is the reciprocal of 5? 1 over 5. And then I can make my negative 2 exponent into a positive 2. Because we've got a 1 in this problem, and 1 to any power is just 1, because 1 times 1 times 1 times 1 is 1, you can just put the positive 2 exponent on the 5 itself. You don't have to put parentheses and put the whole thing to the second. So flip it to the other side of the fraction is what some people like to say. In this second example, because I wanted to make sure we looked at one that had a fraction already, the base for this is 1 over m, And then my exponent is negative 3. So what's the reciprocal of 1 over m? M over 1, right? Or just a plain m. Now I can put my negative 3 exponent as a positive 3. So my answer to 1 over m to the negative 3 is m to the positive 3 power. So you use the reciprocal, or some people it makes more sense if you say that you flip the base to the opposite side of the fraction and make the exponent positive. You're not allowed to make the exponent positive until you flipped or used the reciprocal. So whichever one kind of makes more sense for you. They're really, just a different way of saying the same thing. So let's do a little simplifying. Number one, I've got an a to the fifth, b to the second as my numerator. I've got an ab cubed as my denominator. If you're using shortcuts, you probably already know the answer. If you're not using shortcuts, let's talk about what this looks like. So I've got a to the fifth, b to the second in the numerator. I've got a and b cubed in the denominator. So that means I can start crossing things out in pairs. So an a from the numerator with an a from the denominator. I don't have any more a's in my denominator, so I can't cross any more out. So I'm going to go to b's. I can cross out a b with a b, another b with a b, and this other b that's sitting here is left. There's no other one for it to cross out with. So when I write my final answer, how many a's do I have in my numerator? Looks like there's 4 left, right? How many b's do I have? And where is that b? What part of the fraction? B or b to the first. You can always write a 1 there if you like. It'll just remind you that there is 1. Now for you shortcut people, I see that I've got an a to the 5 and an a to the 1. So when I subtract those, I've got my a to the 4th power. When I subtract my b's, I've got a b to the 2nd and a b to the 3rd. When I subtract those, I've got a 1. But my b to the 1 power goes where the larger exponent was. That is why my leftover b is down here in the denominator, because I've got more b's in the denominator than I had in the numerator. So you shortcut people, be careful when you subtract. Just make sure you know which side of the fraction it's going to be in. We should talk about number 2 because first of all it has negatives. Please make yourself a mental note. Ask this question. Is the negative on a number or an exponent? In this case, problem number 2, that negative 2, is that negative on a number or exponent? It's on a number, right? How about my negative on that 6? Is that 6 a plain old number or an exponent? If it is on a number, there is no reciprocal needed. When it's on an exponent, that's when we're going to do the reciprocal. So ask yourself where that is. So I'm going to break this up into 2 pieces. I'm going to break that up into a negative 2 over negative 6. I'm going to break that up into a k to the 2nd, k to the 6th. I'm going to take that fraction right off the front of there because we simplify that like a fraction. If you just had a negative 2 over negative 6 and I said simplify that fraction, what would you tell me it was? 1/3, right? Our fraction is done. Those guys are simplified. Even with those negatives, negative over negative became a positive. So now let's talk about these k to the 2nd and k to the 6th. I've got 2 k's on the top, 6 k's on the bottom. If I start crossing out, or if I'm doing a shortcut, how many k's do I have left? And will they be in the numerator up with the 1 or the denominator down with the 3 for my final answer? That k to the 4th is down in the denominator because I have more k's. I have 6 of them and I only have 2 on the top. So my answer for this is 1 over 3k to the 4th. So even though I picked those two apart and did one fraction and one k problem, I still put them together as one big fraction for my final answer. All right, so let's talk about number 7. I've got 7 to the negative 2. This is just like that example that we did with the 5 to the negative 2, I think it was. So since I've got a negative on my exponent, the 2 that is negative is an exponent, which means I'm going to have to do a reciprocal. What's the reciprocal of 7? 1 over 7. Now that I've done the reciprocal of 7, I can make that exponent 2 a positive. Well, 1 over 7 to the second power is 1 over 7 times 7, or 1 over 49. So let's look at negatives with more problems. Notice number 8, I've got a 4 over 5. That's just a fraction, right? So I know in my answer I'm going to have a 4 over 5. I've got C's. Notice that bottom C has got a negative on the exponent. So in order to make that C to the negative 4 into a C to the positive 4, what am I going to have to do? This is where thinking of it as putting it to the other side of the fraction, flipping it over, it helps out. So I'm going to take this C to the negative 4. I'm going to bring it around to the top of the fraction since it started in the denominator and make it a C to the positive 4. And then I'm going to cross that out because I already took care of that. I'm going to worry in a second about what else is going to happen because I see another negative exponent. This D is to the negative 2 power. So in order to make a positive, we can't do anything with a negative. In order to make a positive, since it's on the top of the fraction, where am I going to put it? And when I put it down on the bottom of the fraction, it's going to become D to what power? Positive 2. I cross that out because I know that I took care of that. So at this point, looking at my mess up above, I still have the C to the 3rd that was already there. I've got the C to the 4th that I brought up to the top. On the bottom, I have the D to the 7th that was already there. And I put the D to the 2nd that I brought around to the bottom. Now everybody's going to tell me I can simplify this, right? If I've got a 4C to the 3rd, C to the 4th in the numerator, if I've got 3 C's and then I'm putting 4 more C's on there, how many C's do I have for my numerator? In the denominator, if I've got 7 D's already, and then I put 2 more down there with those D's, how many D's do I have? You shortcut people are going to know, oh, I just added those. So I had the 5 already, D to the 9. And that is my final answer. Once you work with these negative exponents more, they do get easier, and it's getting the hang of putting them in the other part of the fraction. Let's talk about this area of a rectangle. The area of a rectangle is 32, x to the 4th, y to the 6th. Find the length of the rectangle. Well, hopefully you know that area is length times width. And it looks like this is what we're looking for, and this is the width. But it tells us the area, right? So how are we going to figure out what the length is if we know that this is 8x to the 3rd, y to the 2nd, and this is what L is what we do not know? You're going to tell me that we could divide, right? Divide by the width we know. Some of you probably aren't thinking of it like an equation, but you're just going to know that you're going to take the area, you're going to divide by the width. That will tell us what's left. So my area from the problem is 32, x to the 4th, y to the 6th. I would pay attention to this problem because I promise you this is coming back around. And then the width that we know is 8x to the 3rd, y to the 2nd. This looks exactly like the problem that we were just doing. We've now, ignoring the whole diagram and everything else, set ourselves up a problem. I have no negatives to even think about. I do have, however, a 32 and an 8. Would you simplify a 32 over 8?
If there are any river...
So 32 over 8 is going to simplify down to a 4 over 1, right? And you don't even have to write that 1 down there in the denominator, but you can. What about when I look at the x to the 4th? And the x to the third, well, this is 1, 2, 3, 4 x's. This is 3 x's. If I start crossing x's out, how many x's will I have left? And where will that 1x be? Up in the numerator. I've got y to the 6th and y to the 2nd. So 1, 2, 3, 4, 5, 6. If you're writing these out, you'll get better at these as you go. If you need to see them, then write them out. So a y with a y, another y with a y. How many y's do I have left? And where will those y to the 4th be, the top or the bottom? There we go. So we have got ourselves an answer for the length for this problem. It's 4xy to the 4th. We could put 4xy to the 4th over 1, but we don't have to. We could just call it 4xy to the 4th. All righty. So we're practicing, and we'll practice more. If you're struggling, having a hard time, bring your questions to class, and we'll talk these things out. But here's what I would like to know. What do you do when you have a negative exponent? And actually, I want to add to that, what do you do when you have a zero exponent? So 2 questions. What do you do when you have a negative exponent? What do you do when you have a zero exponent? And here is your practice problem. Simplify. I've got an x to the 3rd, an x to the 0, and an x to the negative 5. I have way too many x's. I want my answer to be x to some power. It might help to think about if we were going to make this into a fraction, this whole thing is over 1. Because that x to the negative 5, that third parenthesis, nobody likes a negative exponent. We have to flip it to the other side of the fraction before we can make that an x to the positive 5. Then you'll be able to take care of things. So 2 questions have to do with this practice problem. One of them has a negative exponent and one of them has a zero exponent. That's it for section 7-2. And bring your questions to class. Go back and rewatch if you missed something, and we will talk about this when we get to it.